Hey, good morning, everybody, and welcome to our pre-calculus 40S class. Today, what we're going to do is we're going to start the chapter 6, and we're going to be focusing on lesson number 1, which is on trigonometric ratios for angle in standard position. Now, when we get into something like this, it says an angle in standard position is where the vertex is located at the origin, where the point is 0, 0, and its initial arm lies on the x-axis. So the standard position is where the line is, it starts at the origin, the vertex, where it's rotating, and then it starts off at the initial arm at the x-axis, and it's going to go around this way. And it's going to either rotate in either a positive or negative direction. So a positive rotation will be counterclockwise this way. And then a negative angle, negative rotation would be going clockwise. And it stops at a terminal arm. So the word terminal means where something stops. So terminal arm. Angles can be measured in degrees, radians, or in rotations. So for today, what we're going to do is we're going to start with measuring the angles and finding the angles in degrees, or using degrees when we measure the angles. Now, before we get into this, I want to kind of give you a background of why that is. It's kind of interesting why we start this way, and then why are we moving counterclockwise rather than clockwise, and so on. Now, the background story about that is actually a connection between astronomy and trigonometry, which are studied in mathematics. So, back in the olden days, like far as time as you can remember, when astronomers are actually mathematicians, and mathematicians are also astronomers. And what they do is that it's fascinating how this is connected to math. What they do back in the olden times is that there's no TV, there's no phone, there's not a lot of books out there, not a lot of entertainment. What they do is they actually look at the sky, and that's what they watch. They look at the night sky, and they marveled around it, and they can see there's some kind of a movement and what's going on around it. So what happens is that, okay, so this is from the of perspective of somebody down on earth. So a person on earth right here is looking at the sky, and it's looking at the sky above, and what happens is it notices that the sun revolves this way. So the sun starts in the east, and then it turns this way, and it sets on the west, and then goes around, and it goes back up there again. So what the parallel between the two of them is that in terms of astronomy is actually affecting how we do things in math. So what's going on in here, now this is a Cartesian plane. That's why when we measure the angle, we start this at 0. That's like a movement of the sun. And then up here, straight up in the sky, and then it sets down in the east, and then it revolves again. So how we do things is that the rotation of the sun is it's actually uh, relative to the person on earth. Okay, this is not really the sun moving, because it's actually the earth that's moving around the sun. So if somebody is looking down on earth, it looks like it starts here in the east and then it falls down in the west. So this is the start, and then this is where it ends and it goes around. So this is where the Cartesian plane starts. And when the sun gets over here, when the sun is there, we get to figure out, well, what is that angle of that sun? What is that angle? So we're looking at the angle right there. And then this part here is like we're asking, okay, well, how high is the sun relative to the earth here? Okay, so this is how high is the sun. And then over here is, well, how far is it over this way? Okay, so all of that, I will probably make some connections later on as we go on with the trigonometry. But what I want to focus on is the angle in standard position. Okay, I want to talk about why are we going this way? And I just kind of alluded that when we talked about the movement of the sun in astronomy, how astronomy and math are connected. So they started off over here. This is the 0 degrees. And then this is we know that over here is our 90 degrees. I'm going to put degrees there. And then going this way, this is 180 degrees. And then going around is now 270 degrees. And then if you go one complete circle, we're going to go to 360 degrees. Okay, so one whole revolution. And then isn't it kind of interesting why it's 360 degrees? Well, some of the stuff that I heard from before is that, when the earth revolves around the sun, it's 365, but instead of using 365 days in a year, they just use 360 because it's a nicer number. So a little bit of history there. So going this way is a positive rotation, so it's going to be a positive angle. So this is the initial arm, and then rotating this way, and that's your terminal arm. That's where it stops. Now we can rotate it. We can also rotate it clockwise in this rotation. And in the clockwise rotation, that's a negative rotation. So this is a 0 degrees. If this is 0 degrees, this is the start. And if we go this way, then this is going to be a negative 90 degrees. And then if we keep going this way, it's going to be negative 180 degrees. And then going this way, negative 270. And then if we do one complete turnaround, it's negative 360 degrees. Okay, so we can rotate counterclockwise, which is positive, and then clockwise, which is a negative. So what we're going to do is we're just going to take a look at this one in here. Example number 1. Sketch the following angles in standard position. So standard position, this is positive 23 degrees. So that means we are going to rotate our arm from initial arm 23 degrees counterclockwise. So rotate counterclockwise. Okay, So I'm just going to write down in here. So this is 0 degrees, and this is approximately 90 degrees. We're just going to sketch. So kind of figure it out, like eyeball it. We don't have to use our protractor at all to sketch it. We're just going to put it right there. So it's going to be between 0 and 90 degrees. It's going to be right approximately there. So this is the initial arm where the vertex starts at 0, 0 at the origin, and it's along the x-axis, and it's gonna rotate this way. So to show that I'm gonna rotate it this way on a counterclockwise, I just go like that. Okay, so I'm just gonna bring it closer. Okay, so it's gonna rotate from, this is the initial arm, and then stopping at the terminal arm, and it's 23 degrees counterclockwise. Okay, so that's that piece. Let's take a look at letter B. Letter B is negative 170 degrees. So where is the negative 170 degrees? Now, because this is a negative angle, we're going to rotate our arm to rotate in a clockwise rotation. Okay, so this is 0. And if I rotate clockwise this way, okay, the word clockwise is the same way as the clock rotates. So this is going to be negative 90. And if I keep going, it's going to be negative 180. And where would the negative 170 going to be? So 0, negative 90, negative 170 would be somewhere right here. So what's happening here is this is in the vertex is at 0, 0. Okay, this is right there. And then the initial arm is right there. Initial arm. And then we're rotating clockwise. Okay, so we're showing our rotation going this way. Okay, it's negative 170 degrees. And this is the terminal arm. This is where it stops. Okay, so that's that one. That's not so bad. Now let's take a look at letter C. Now you're probably thinking, what's going on in here? How do you even graph this 510 degrees? It's like, oh, well, we know that is a positive angle. Okay, so that's a good start. So we know it's a positive angle. So it's going to rotate in a counterclockwise direction. Rotate counterclockwise. So it's going to rotate this way. And now the problem is like 510 degrees. How do we rotate 510 degrees? Is that even possible? So it is possible. We know that one rotation is 360 degrees. Now, if we stop for one full rotation, that's 360 degrees. But if we keep going on, we could go for more angles from there. So this is how I go about this one in here. I do a long division, and really, or you could think about this in different ways too. So you can go 510 divided by 360. So 510 degrees divided by 360. So that's going to be 1. So 1 times 360. So that's going to give us 0, 11. So that's 5, and then that's 100. 150 degrees. So it's going to tell us that it's going to be one full rotation, one full 360, And there's a little bit more that we have to go forward by an extra 150 degrees more. So this again is our initial arm. And then we're going to rotate counterclockwise. So counterclockwise. So if I go like this, and if I stop right there, that's 360. But then I want to go up to 150 degrees more. So well, where is 150? 150 degrees more. That's going to be 0, 90. This is 180. 150 is somewhere right there. So 150 more turn this way. So this is this 510 degrees. Again, starting at the initial arm right here where the vertex is at 0. The initial arm is lying on top of the positive x-axis, and it rotates around 360 and 150 degrees more to get to 510 degrees. Okay, so that's that one. Okay, now let's take a look at letter D. Letter D is going to be, it's a negative angle, so that means it's going to rotate clockwise. We're going to rotate clockwise. And again, if we rotate from 0, negative 90, negative 180, negative 270, and then this is going to be negative 360 degrees, but then we have to go a bit more to rotate a bit more to get to a 490 degrees in there. So this is how I do it. And of course, there's different ways of you can think about it. I go here and go 490 divided by 360. So that means I can go, how many times 360 go into 490? It's 1. 360. So now this is going to be 0, and this is going to be 3 and 130 degrees more. So I'm going to go this way. Remember, I'm rotating clockwise. So this is my starting initial arm. And I'm going to rotate negative 490. So I'm going to go this way. So negative 490. So I'm going to, if I rotate this way, that's going to, and then stop right there. That's negative 360 degrees. Now if I got to rotate a bit more, extra 130 degrees. So where's 130? 100, this is going to be from 0 to 180 there. So it's going to be around here. 2. And then we're just sketching here. So right there. Okay. So starting here, the negative, it tells us it's going to be this rotation clockwise, and it went around 1 full rotation and a bit more. So that's going to be a negative 490 degrees. Okay, now let's do this one here, 1,200 degrees. How do we fit 1,200 degrees in our, how do we sketch that one? Okay, again, this is a positive angle, so that means rotate counterclockwise. Okay, and then how do I fit that in here? Like, where does it end, right? So that's what you were thinking about. Where does the terminal arm go? Is it in this right there? Like where? So let's do the same thing. We're going to divide 1,200 by 360. So 1,200 divided by 360, that's going to be, we can fit 3 rotations in there. 3 rotations. So 3 rotations, what happens to the 3 rotations? 3 times 360 is going to be 1,080. Okay, so if we go 3 rotation, 1, 2, 3, that's going to give us 1,080 degrees, but then we need to go a bit more. So that's going to be 0. Okay, and then we need 120 degrees more. Rotate 120 degrees more. So 0, 90, 180, 270. So how many rotation? We're going to have a 3 full rotation, starting with the initial arm. This is the initial arm. That's where I'm starting. I'm going to do 3 rotations. So 1, 2, 3 rotations. Okay, so I'm on my 3rd rotation, and then I have to go 120 degrees more. So from here, if I go and then 90 more, and then another 30 degrees, so that's going to give us, okay, this is where the terminal arm is going to be. So it's like here, rotating 1 rotation. Oops, sorry. And bring this up a bit this way. So this is your initial arm, and then we go rotation 1, rotation 2. So that's going to be its 2 rotations of 720 degrees, and then another rotation that's going to give you 1,080 degrees. And then if I do 120 degrees more, then that's going to be 1,200 degrees. Oh, and then I have to put the arrow showing the direction of which I'm rotating. So I'm rotating counterclockwise. And then finally, they ended up with negative 87 degrees. So the negative tells us that this is going to be a clockwise rotation. Clockwise rotation. So we're going to go a negative rotation, so 0, and going this way. So this is going to be negative 90, negative 180. So if I'm going negative 87, so this is my initial arm. This is where I'm starting, and it's a negative degree, negative angle. So we're going to rotate clockwise 87 degrees. So it's just going to be somewhere right there. And we have to indicate that it's turning this way. So negative 87 degrees. So the arrow tells us which direction it's going. And that's important later on. Okay, so that's example number 1, just drawing it out, and I kind of talked about where this, how this is connected to astronomy and some science. So what we're going to do, we're going to talk about coterminals. Coterminal. Well, what's a coterminal? Okay. The word terminal is where it stops. So terminal angles is where the arm of the angle stops. And then coterminal means there's other angles that actually stops in the same place. So as it goes around, it could potentially stop in the same angle or same place. So angles in standard position with the same terminal arms are called coterminal angles. There are infinitely many angles that are coterminal with a given angle. So they kind of gave us, this is important, so I'm going to put a star beside it, and I'm going to box this. Okay, so it says here, given any angle theta. So if you could think of any angle, and we call it theta, all of its coterminal angles can be defined as in terms of theta. So what does that mean? Okay, so I'm just gonna go grab a piece of paper in here and then talk about that for a second. So let's start with, I'll explain that for a second. So this is our initial arm. Let's say theta is equals to 30 degrees. 30 degrees right there. Okay. Now, I could land on the same arm, terminal arm, if I go that way, right? I stop on the same arm. But then how did I get to that one? Well, that's basically from here to here, that's 360 and another 30. So I could stop at the same terminal arm by taking 30 degrees plus 360 degrees. Well, what else can I do? Well, if I could go like this, what if I don't stop there? Again, let's say this is my 30-degree angle, my theta. Let's see, how can I get to that one again? Stop in the same terminal arm. I can go start here. That's my initial arm. This is where my initial arm starts. And I go around 1, 2. Okay, so how did I get to that one? I went around once, twice, and I did 30 degrees more. I landed onto that same place. So I went 30 degrees right there, plus 360, plus 360. Okay, so I can keep doing that so many times. And then these ones just tells me how many 360s do I have to turn. So that's where theta plus 360 times k. And then you're probably thinking, well, what's k? K is the number of times it's going to rotate. Now, those are positive angles. I'm going to bring it up again here. What if I start here? Again, this is my 30 degrees. And if I turn, this is where I start. Okay. And then if from here, I rotate, from here, I rotate this way. Okay, this is my initial arm. What if I rotate this way? I end up with the same location over here. I'm going to end up with the same terminal arm, but we're thinking, oh, we actually rotated this way, but we end up with the same terminal arm. So what angle is that? So that's basically 30 degrees minus 360 degrees. That's actually negative 330 degrees. Okay, well, what if I keep going? What if I go there and then go this way? So I can go 30 degrees minus 360 and another 360 degrees. And then it's going to tell me how many degrees that's right there. So that just explains what this one is. So given an angle theta, when they say all of its coterminal angles can be defined in terms of theta, where k is an element of z, and then that means z is integers. which tells us like how many rotations is it. So either one rotation, so k integer, two rotations, so k is 2, three rotations, that means k is 3. And we could choose negative as well. So let's take a look at example number 2. Determine the measures of all angles in standard position that are coterminal with 50 degrees. So determine the measures of all angles. So all angles. So it's going to be our theta. Here is 50 degrees. So when we talk about all angles in standard position, it's a coterminal. That means it stops in the same place as 50 degrees. It would go like this. 50 degrees plus 360 times k, where k is an element of an integer. Okay, so I'll give you some possibilities in here. So it's going to be 50 degrees plus 360 times 1. That's going to give you 410 degrees. So if we actually graph 410 degrees, it will land as in the same place as the angle in 50 degrees. You can go 50 degrees plus 360 times 2. That's going to give us 360 times 2. Okay, 720 plus 50 is 7 times 2 plus 50, 770. Okay, 770 degrees. So if we plot this, or if we graph this angle at 770 degrees, it will line up as if it's a terminal angle at 50 degrees. Now, if we do a negative rotation, I'll start off with 50 plus 360 times 0. So 50 plus 360, 0, that means we don't do any full turn. That's where we're going to be at 50 degrees. And if we go 50 plus 360 times negative 1, we're going to get a negative 60 minus 50 is going to be negative 310 degrees. Okay, so those are a few ones. Okay. Now this is going to be really, really interesting when we see this graph on a trig function. So right now we're like baby steps, learning all these things. I keep talking about baby steps and we can't take it for granted. Now letter B, determine the measures of angles between negative 720 degrees and 720 degrees that are coterminal with the angle theta, or angle 20 degrees. So they're saying theta is equals to 20 degrees. So now we want all angles, but then it's restricted to negative 720 degrees and positive 720 degrees. So we're going to look at all coterminals between this negative 720 to positive 720. So how do we do that? We know it's going to be 20 plus 360 times k, where k is an element of integers. Okay, so either 0, 1, 2, 3, 4, 5, and a negative 1, 2, 3, 4, 5. So let's go here. 20 plus 360 times 1. That's going to give us 380. Okay, so that 380 degrees is within that limit there, that the limit of negative 720 to positive 720. Now if we go 20 degrees plus 360, if we rotate it 2 times, so what would that be? 20 plus 360 times 2. Now we're going to get into, 20 plus 360 times 2 is going to get into 740. So this one here is not going to be part of our solution. Okay, so no, not part of our solution. So we have 1, 2. What about negative 1? So 20 plus 360 times negative 1. That's going to be negative 340. Okay, so that's still good. That's good. That's still within that parameter right there. And then 20 plus 360 times negative 2. That means we are going to be rotating two turns clockwise. So 220 plus 360 times negative 2. It's going to give us negative 700 degrees. Okay. So what are the coterminals? So coterminals of 20 degrees, it's going to give us negative 700 degrees, negative 340 degrees, and I'm going to include the 20 degrees there, and 380 degrees. Okay, so those are the coterminals. Take a look at letter C. Determine one positive and one negative angle coterminal with 130 degrees. So they're telling us theta is 130 degrees. Now we're going to look for one positive and one negative. So 130 plus 360 times k, where k is an element of an integer. So if it's a positive and one negative, it's going to be 130 plus 360 times 1. That's going to give us 360, 130, 490 degrees. And then that means 130 degrees, and then rotating it by another 360, or 360 rotating it another 130 degrees. Or we can go 130 degrees plus 360 times negative 1. That means rotating it negative 360 degrees is at negative 230 degrees. So these are the one positive, one negative. Okay. And then let's take a look at letter D. I'm probably just going to finish off D and E for today. I'm going to do a slow start on trigonometry. So in this particular case, determine one positive and one negative angle that are coterminal with angle of negative 70 degrees. So the theta here is negative 70 degrees. So it's going to be negative 70 degrees plus 360k, where k is an element of an integer. Okay, so we go negative 70 plus 360 times 1. It's going to be positive 290 degrees. That's the positive coterminal. And then negative coterminal would be negative 70 plus 360 times negative 1. It's going to be negative 430 degrees. Okay, so finally, letter E. We're going to look at the measures of coterminal angle, and it has to be between negative 600 and positive 600. So our theta is negative 35 degrees. So to find all of the possible coterminals, we go theta negative 35 degrees plus 360 times k, where k is an element of an integer. So let's see, we can have from negative 600 to positive 600. I'm going to go negative 35 plus 360. If I go negative 2, that means negative 2 full rotation, right? Because 360 is a full rotation. So negative 35 plus 360 times negative 2. I'm going to get a negative 755 degrees. Negative 755 degrees is outside negative 600 and a positive 600. So this is not part of our solution, okay, because it's not within that limit, that boundary there. Let's try negative 1. So 35 plus 360 times negative 1. That's going to give us 395. Negative 395, and that's within that limit there. So this is part of our solution. If I go negative 35 plus 360 times 0, that's just going to give us negative 35. Okay, and that's within that limit. Well, that's that one right there. And then if I go negative 35 plus 360 times 1, it's going to give us 325 degrees. So that one is still the limit. Now, I think if I continue on, I'll just continue on. If I go 2 full rotations, that's going to be negative 35 plus 360 times 2. It's going to give us 685, which is over the 600 there. So this is not, so that means these are the only 3 coterminals. So the only coterminals of negative 35 degrees between negative 600 degrees and 600 degrees are, okay, these 3, negative 395 degrees, negative 35 degrees, which is that exact theta, and then 325 degrees. Okay, so I think what I'm going to do is I'm going to stop right here. And I know some of you are probably still working on your test, and so stop right here. This is a good place to just kind of start but not overdo it. So I won't start anything in terms of assignment. I won't really practice assignments yet, but just for you to just either finish your test and then hand it in as soon as you're done. And then you can just um, write this notes down and then we'll just continue on tomorrow. Okay, so for today, I'm going to leave that with you. And I hope you had a uh, good learning time. And like if you have, like I've said before, that if you have any questions, please do not hesitate to email me or send me a message through the blog, and I'll try to get back to you as soon as possible. Okay, well, have a good day, and I'll talk to you again tomorrow. Okay, bye bye.